Hi everybody, thanks for coming. I'm Natalia, I'm a workflow developer in the EPI2ME team, and I hope that you have already heard about it, but if not, you are in the right place, because I'm just going to introduce briefly the app, showing you the new exciting updates, coming updates, and then I will just introduce our guest, Jimmy, that will show you how to make the most of it by running your own workflows. So our goal as a team is to create workflows at the infrastructure needed to analyze Oxford Nanopore technology sequencing data and make it available for everyone. So our workflows take as input base call data, and they provide you with a report that gives you a first overview of your results. We use Nextflow as a workflow management system to make the workflows run as efficiently, and to ensure reproducibility, we package our workflows in Docker containers to manage external software. Currently, we have available 17 workflows that we are constantly updating, and also new workflows that will come. But we do this based on your feedback. So your feedback is truly appreciated and warmly welcome, and hopefully, if you come to us and give us your suggestions, you will be able to see some of these in the future releases. So please join here these days and give us your feedback. So our workflows are available in GitHub, so you can go to the repos, read documentation, fork them, and even adapt them to your needs. So and run them in the command line. But then you have also another option, which is run them within the app. You can download the app for free from our web page, and it will run in Mac, in Windows, Linux, and also in our sequencing devices like Gridiron or Prometheum. So also you can run the workflows in the laptop. You can run the app in the laptop. You can run that in the cloud. That's now in early access. So if you are interested, please let us know during the conference. And also, as I mentioned, in the devices. So, just to show some of the new upcoming features, it's like a new improved interface. And also, we have embedded IGV panel so that you don't need to open another software to show to visualize your alignments or to visualize your variant calling. You can do it within the app. It will be integrated there. Also, we are happy to announce that we will be releasing Jupyter notebooks also within the app. So again, if you want to do downstream analysis, you have it within the app. And another upcoming feature is tertiary analysis with trusted providers to perform onboard annotation and exploration, like, for example, with the partner GenX, to identify genetic variants with GenX specialist databases and data explorer tools. Last but not least, for those that don't want to or have not access to internet, we are happy to announce the EPI2ME format that will allow you to share workflows offline. But one of the main reasons of being here is to tell you how can you make the most of the app by running your own workflows. We provide a template that you can fork from our GitHub, and you can use it as a starting point to then make it compatible with the app. And for doing this, it's my pleasure to introduce Jimmy. Jimmy works as a bioinformatics consultant in Prairie Diagnostic Services. He's also a PhD candidate in the Simon Fraser University. And he's the lead developer of Hsiao, which is a workflow to perform Salmonella serotyping and in real time. So I'm just going to let him to show how you can do this. So thanks, Jimmy. Come here.
Thank you for the kind introduction, Natalia. Super excited to be here to tell you all about our recent developments of a real-time bacterial genomics workflow that we like to call Hsiao, which you can see on the screen here. And so in a moment, I'll be walking you through how you can actually run this workflow in EPI2ME fairly easily. But before we dive right in, I do want to set the stage here a bit to first explain that, as Natalia mentioned, I'm affiliated with a veterinary diagnostic lab in Canada, And we're constantly on the lookout for innovative solutions that can help expedite the detection and the reporting of infectious diseases. And the application that we'll be looking at today is fairly straightforward, but also a very important one. I'm referring to someone serotyping. And so what we'll be looking at today is how do we confidently predict someone's serotypes from whole genome sequencing data in real time. And this, of course, is highly critical to our ability to rapidly respond to the emergence of pathogenic strains of Salmonella. So without further ado, let's jump straight into the demo. So let's switch over to my computer screen. Okay, so what we're looking at here is the graphical interface of the application EPI2ME, and I've already gone ahead and imported the workflow into the application. And if you're curious on how to do that exactly, we do have instructions on our GitHub page. I've also created these tiny flashcards that you're welcome to pick up at the very end, which has this QR code that you can scan to find our GitHub page as well. So first, what we're going to do is we're going to get this workflow up and running. And after that, we're going to try and simulate a sequencing experiment. And so, unfortunately, because of time constraints and resource constraints, we can't really load a flow cell and do an actual sequence experiment live. But what we can do is we can try to emulate or mimic a sequencing experiment as closely as possible by doing some base calling. So we'll take a look at that in a bit. So what we're going to do first is we're going to launch this workflow by selecting workflow here, and we're going to select run this workflow. It's going to take a couple seconds to do some back-end dependency checks. Hopefully that wouldn't take too long. And then we're going to click continue. And so this will bring us to the run setup page. And so what we need to first configure is our input data. However, we don't have any sequencing data at the moment because we'll be generating some sequencing data on the fly. But what we can configure, though, is where the sequencing data will be. And so I'll be populating this watch third parameter to indicate to the pipeline where it can expect to find some sequencing data. I'm going to go ahead and select that, and I've already pinned this in quick access. It will be in the LC demo folder, and we'll be depositing sequencing data in this base calling folder. And then I'm going to jump over to the data quality check and turn on this QC option, which performs various sequence quality checks so that we can actually monitor the quality of our sequences over time. Now, in order to use this QC option, we also have to provide a centrifuge database as described here. And so I'm going to go ahead and select a pre-downloaded centrifuge database index. Now, there are a few other quality filtering parameters that we can play around with, but I'm not going to touch it here. But I'm going to scroll all the way down here and disable genome polishing. Normally, I don't like to do this, but simply for the interest of time, in order for us to speed up the time to results, I'm going to disable genome polishing. And then I'm just going to skip over to the real-time options and then increase the number of CPUs allocated to this run. Normally, I would recommend, if you want to get that immediate feedback, I would highly recommend to have at least 64 cores, CPU cores for this analysis. And then once we're happy with all the settings, we can then go ahead and launch the workflow. And so it's going to take a couple seconds for it to spin up. So let's wait for that. Okay, so that will bring us to this screen where we can actively monitor the progress of the different processes in the pipeline, as well as any output file that are generated by the pipeline. I should mention there is one process in the pipeline that is not dependent on any input data. And so I find that is a very useful green flag to indicate that the pipeline has successfully initialized. And so here we see that there is one process happening and it has completed successfully. So that tells me that the pipeline has been initialized and is currently waiting to receive data. And so now this is where we then shift over to our gridiron, where we're going to do some base calling. So let me just exit out of this screen and go to our gridiron here. So we're going to do base calling in the Minnow app. So I'm going to click analysis, and we're going to do base calling on some FAST5 data that we previously generated. And so that's also in the LC demo folder. So, and then we got some FAST5 data here, which contains 3 barcodes. And we're going to click continue, Now we have to select where we want to write our base calls to. Now this is very critical because we have to make sure that we write the base calls to the same folder that is currently being monitored by our pipeline. And if you recall, that corresponds to, again, the LC demo folder. And it'll be the base calling folder. I'm going to go ahead and select that. And now all there's left to do is to indicate what is the flow cell type. So this is Flongo data, by the way. Just going to select Flongo, and then we're going to use high accuracy base calling. We're going to click continue, and then we're going to indicate the barcoding kit, which is native barcoding. Also going to turn on barcode trimming for the convenience. And then once we're happy with all the settings, we're going to start the base calling process. Okay. And so it's going to take a couple of seconds for it to warm up. And so we're going to give it a couple of seconds. Once it starts to generate the base calls, then we'll switch over back to the EPI2ME application. So hopefully this doesn't take too long to warm up. Okay, so we're starting to see some estimated time, which indicates that base calling is now happening. And so now we're going to switch over back to EPI2ME. Okay, so there we go. We see some activities happening, which indicates that the pipeline is currently processing and producing the results in real time. And so these results are also being actively compiled into interactive reports, which are usually in HTML format. So we can actually scroll down here to see if any HTML file has been generated. And we can see that there is one HTML file already generated. So we can actually head over to our report tab. So this is a report generated using a tool called Nanocomp, which reports very detailed sequence summary statistics of the raw sequencing data at per barcode resolution. And so here, each column corresponds to an individual barcode. And it reports statistics such as the total number of reads generated, the total number of bases sequenced, the average read length, as well as the average read quality score. And so the idea is that as we're generating these base calls, as we're generating new information, the pipeline is iteratively updating these reports as new information becomes available, and to ensure that these reports are reflecting the most up-to-date information. Now, this is just looking at raw sequencing data quality. The pipeline behind the scenes is also performing taxonomic classification, genome assembly, assessing the genome assembly quality, as well as, most importantly, somewhat serotyping. And all those information are being compiled in a separate report, which we will now look at. Now, in the interest of time, I'm just going to directly show you what that report will look like by the end of the run. And so this is what it would look like. And so here we can actually see, not only do we get the total sequencing output, if we scroll over to the right, it also reports the microbial composition of your samples. And if we switch over to the second tab, you can actually see the taxonomic classification at the individual species level. And you can see that majority of these reads are in fact Salmonella. Now, if we do manage to generate some form of genome assembly, then we can actually go to the assembly statistics tab, which will report the quality of those genome assemblies that we have successfully generated in terms of total length, completeness, contamination, contiguity. Now, based on these genome assemblies, we can then start to predict some of the serotypes for the individual barcodes. And then this is where the serotyping results come in, which allows us to actually look at what exactly are the serotypes of the individual barcodes. Now, there is a second tab here, which is called temporal tracking, which provides you that temporal dimension, meaning that we can actually look at these different sequence metrics as a function of time. And so we can actually go to the assembly statistics tab, which would actually tell us as sequencing time goes on. Let me just switch over to the contiguity tab. We can see that the assembly size grows exponentially We can also see that the number of contigs reduces exponentially, indicating that these genomes are becoming more and more contiguous as we generate more sequencing data. And if we look at the marker gene analysis, we can actually see that these genomes do become more and more complete over time. And so with this pipeline, we're not only just striving to improve the diagnostic turnaround time. What we also hope to accomplish here is providing you with actionable insights for your sequencing experiments by actively reporting or returning data and results that can be much more easily interpretable and ultimately leading to more informed decision making. And so on that note, I will end the demo here. I'll invite Natalia back to the stage. Thank you very much.